My dear students, uh, this summer semester I am taking you the subject that is Introduction to Electronics Engineering. Previously, this subject is called as Basic Electronics. So several times, so many times I have taken this subject, Basic Electronics. Here in this subject, we are having so many concepts. In that, first, the all the concepts, all the subject, complete subject is divided into five modules. First module, second module, third module, fourth module, fifth module, like we are divided into the modules. In first module, we'll discuss about power supplies. Powers in the first module, power supply. Afterwards, we'll discuss few more, first part of first module is in first module we are having two parts, that is power supplies, and another one is about few more concepts are there that I will discuss in the next video lectures. For in first module, the first in first module the first part is related to power supplies. Power supply means what? Power supply means here, suppose here this is a input AC supply. The supply, whatever the supply coming to the our houses, it is in the form of AC. This is alternating in nature. This is alternating. It is having both the positive half wave and negative half wave. This is AC. It is called as AC supply. This will be having both the full positive half wave, negative half wave. In houses here, in all the house application, in our home, whatever power, whatever electricity it is coming, it is in the form of AC. There are two types of electricity or electric supplies, that is AC supply and DC supply. DC means it is constant. This is nothing but output of the regulation. This is with respect to time, the current or voltage is constant. Suppose 5 volt means 5 volt, 10 volt 10 volt. If the current 5 ampere, it will be constant throughout all the time. With respect to time, it is constant. Whereas in AC, with respect to time, every instant it is varying. This instant it is zero. After some time, with respect to time, it is increasing. At this instant, voltage is maximum. At this instant, it is once again it is decreasing. Here once again it is zero. Now it is negative, like this, negative maximum. Like every instant there is a change in the voltage, change in the current. Therefore, such supplies are called as AC supply. Whatever the supply which is coming to home, it is in the form of AC. Why it is in the form of AC? Because where the power is generated, here the power is coming from Raichur. Here, the Raichur thermal power plant, it supplies the power to nearby districts, not only to Raichur, Gulbarga, Bidar, so many nearby districts, the power is coming from there because the huge power in terms of so many mega watts, gigawatts, that is generated in the thermal power plant which is near to Gulbarga is Raichur. We can generate the electricity from thermal power also, from hydropower also, from wind power also, from water, solar power also. It is not necessary we should have the thermal power. It is not necessary that we should have the hydropower. It is not necessary that we should have the thermal, that is wind power. Any form of energy can be converted into another form. Already we know that that is an energy neither be created nor be destroyed, but only it is transferred from one form to other form. Even using solar energy also, we can generate the electricity. Using wind energy also, we can generate the electricity. Using hydro means water also. Suppose you go in South Karnataka, like Bangalore, there the water which is coming from Joke Falls, it is water is falling from above height. in that, from that energy also, that water energy in the under that one, they have placed the armature. By rotating the armature, they will generate the electricity. We know already how the principle of generation of electricity, how we can generate the electricity. That is, mechanical energy is converted to electrical energy. Some armature will be there which is placed in between the magnetic fields. By rotating that armature, due to cutting of magnetic lines of forces, the electricity EMF is generated, electromotive force. From that, the electricity is generated in all the, if we, whether it may be thermal power, whether it may be wind power, whether it may be hydropower, all concept is same. Mechanical, they what they will do, they by somehow they rotate the armature, which is placed in between the magnetic field. Due to cutting of magnetic lines of forces, the electricity is induced, the electricity is generated. That is, therefore, here in all the houses here in Gulbarga, or in all the fields, we are having the AC supply. But in some applications, for example, mobile charger is there, but this is whatever it is coming to home is how much voltage? 230 volt. That much use power it is there. Suppose I want to charge my mobile, I can't you use that to 230 volt. Suppose directly I will apply 230 volt to my mobile will blast. Why? Because that much use amount of voltage, my mobile can't tolerate. Yeah, for charging my mobile, it requires only 9 volt DC, that to DC supply. it, for that we should have this is output of this is DC supply. DC means it will be constant, it will be constant. This is constant with respect to time, whether it may be 5 volt, it may be 10 volt, whatever, 5 volt, 10 volt. This means why it is DC means what? It will be constant. DC time with respect to time. 5 volt means 5 volt constant. Every instant, for this instant with respect to time, 5 volt. This instant, 5 volt. This is instant, 5 volt. Every throughout the time axis, the voltage or current remains constant. Therefore, such supplies are called as DC supply. This is AC supply. AC means alternating, which is alternating with respect to time. Every instant it is changing. Therefore, this is power supply means using all these rectifiers, filters, and regulator will convert this 230 volt to according to our requirement. Whether suppose I want 5 volt, then using the rectifier, using the filter, using the regulator, we can have 5. Some ICs are there, regulator ICs are there. That is, I think 78805 is a regulator IC which will convert the output of the filter as perfect 5 volt DC. That is regulator. So from that, for example, my mobile charging, I require charger. You know that you suppose you are having mobile, definitely you should have the charger to charge the mobile, because after one day the battery will be low, the battery power will be down. At that time, what you will do? You will recharge with using the charger, battery charger. In that charger, it contains nothing but this input AC supply. Transformer will be there, rectifier will be there, filter will be there, regulator will be there. So that using these components, we can convert 230 volt heavy volt to, for example, 5 volt, 9 volt. For my mobile charging, it requires 9 volt, that to DC supply, not AC supply, DC supply. Therefore, we have to use the rectifier, we have to use filter, we have to use regulator, so that we can get perfect 9 volt DC. Therefore, we should know how we can convert a 230 volt AC to 9 volt DC. That is called as power supplies. In that this is the input supply. Then comes the rectifier. This is the output of the half-wave rectifier. In rectifier also, so many types of rectifiers are there. Half-wave rectifier, full wave rectifier. In full wave rectifier, once again we are having full center tapped full wave rectifier, bridge rectifier. Like three types are there in the rectifier. This rectifier, half wave rectifier means we will not have only we have only the positive half cycles. We don't have the negative half cycles. Therefore, such output is called as half wave rectifier. Full wave rectifier means here suppose this is the output. Here full wave rectifier, what happens, it will convert this negative cycle also, this also convert into positive. This is the output of the full wave rectifier. This is what output of full wave rectifier. In full wave rectifier, what happens, this negative cycle also convert into positive cycle. This also convert into positive cycle. Therefore, this is how rectifier. Then here in this rectifier, see, it is not perfect DC, even that is having the ripples. Rectifier means what? A rectifier is a device which will convert the AC supply to DC supply. DC means it is not perfect DC, even though it is having so many ripples, so many AC component in this rectifier. Therefore, what will do? Use filter. Filter also not removes all the AC components. Even some ripples will be there. Filter means we can use inductor as a filter. We can use capacitor as a filter. Here in filter also there are two types: capacitor as a filter, inductor as a filter. Next we'll discuss about that also. Afterwards, before that, we'll discuss about in detail about half wave rectifier. What is half wave rectifier? What are the some terms are there? Some that is IDC, IRMS, VDC. So many some terms are there that you should know. So from knowing that one, we can solve problem related to half wave rectifier. Then comes filter. Filter also we'll discuss in detail in the first part of the first module of this basic electronics. Then afterwards, the output of the filter is given to regulator. Here in power supplies, for 5 volt, we use 7805 IC as a regulator, so that even some ripples are there which will be removed and the output will be perfect 5 volt DC. Like how we can convert AC to perfect DC. Whatever, suppose you want 5 volt, 5 volt, 9 volt, 9 volt, 12 volt, how much you want, depending on that, we have to select the regulator. Depending on that, we have to select the transformer. Depending on that, we have to select the components in the power supplies. This is about power supply. Afterwards, we'll discuss in detail about what is half wave rectifier and how we can convert the AC component, AC to half rectifier. That we'll discuss in this book. He has given about the half wave rectifier. Half wave rectifier, that is rectification. Here, rectification means what? That is converting AC to DC. AC to DC is called as rectification, means converting a device which will convert alternating current to direct current is called as rectifier. I already told that it will not completely convert AC to DC, even though so many ripples will be there in the output of the rectifier. Using filter, using regulator, we can remove the AC component which is there in the rectifier. Simply, how we can define the rectifier? Rectifier is a device which will convert AC to DC. That is called, the process is called as rectification. In that, first we'll discuss about half wave rectifier. Half wave rectifier means here, as I already told that half wave rectifier, this is a circuit of half wave rectifier. Here 60 Hz AC supply. This represents the symbol of AC supply. AC supply 60 Hz, and here this is the transformer, primary and secondary. Diode. This is about half wave rectifier. Here diode is used as a rectifier. Diode, I think you know what is diode. Diode is nothing but combination of P-type semiconductor and N-type semiconductor. That is called as a diode, and this is resistor RL. Therefore, using AC supply, using diode, we can convert. This is AC supply. Output of the transfer from this transformer. Here, transformer. Why we use transformer? Transformer converts or step up or step down the AC supply. Means if it is 230 volt, here we can have 12 volt AC supply, 15 volt AC supply. But it will not convert AC to DC. Only it will step up or step down the AC voltage. For rectification, we use a diode. Diode as a single diode used for half wave rectifier. For full wave, we require two diodes. In full wave, we are having we use bridge. Four diodes will be used for bridge rectifier. There also we can convert the AC supply to DC supply. Here, this is the primary windings of the transformer. This is the secondary windings of the transformer. When you apply AC supply, here AC supply is there. When positive polarity is there, when positive polarity is applied, at that time, this becomes this. You should know what is diode. It is having P type and N type. This is called as anode. This is called as cathode. When positive is applied, at that time, as good as you have applied positive here and negative here. When positive is applied to anode, negative is applied to cathode, it becomes forward bias. I think you should know. You already know. I think I thinking that what I am thinking already you know all the concepts of diode. What is forward bias? What is reverse bias? Afterwards only I'm telling this. But previously, what we'll do while discussing about the half-wave rectifier in the syllabus, we are having about the semiconductor. What are the semiconductor materials? What is P-type semiconductor? What is N-type semiconductor? What is forward bias? What is reverse bias? Everything we'll discuss in detail about that one, so that students can come to know all the concepts. What do you mean by forward bias? What do you mean by reverse bias? Why during forward bias the diode conducts? Why during reverse bias why it will not conduct? But here in this new syllabus they have not included all those concepts. I think already you know that. I think you know. If you don't know, you can ask to me. I will explain all the things. Therefore, when positive is applied to anode, negative is applied to cathode, this becomes forward bias. When it becomes forward bias, it will allow electric current to flow through it. It acts as a switch, closed switch. Current can flow through it, and it will come to the load resistance. Here we'll get output. Same whatever there here. And this is output from transformer half wave rectifier. Output of the half wave rectifier. We will get this one. During reverse bias, during a negative cycle, what happens? Now I'll analyze the behavior of the circuit. During this half negative half cycle, what happens? During this negative half cycle, what happens? Point A becomes negative, point becomes positive. Here, as good as we are applying negative polarity to anode, positive polarity to cathode. When we apply negative polarity to anode, positive polarity to cathode, it becomes reverse bias. Reverse bias means open switch, or there is no when current flows. When current flows, there should be a closed path. Then only current flows. If there is no closed path, current never flows. For example, there is one path, one road from my college to from my home to PDA college. In between, some road work is going on. How I can go to college? If alternate path is there, no problem. If only one path is there, then never, impossible. I can't go to college. Like here also, if this is open, this is not closed, it acts as open switch, then current will not flow in the circuit. Why current will not flow? This becomes reverse bias. Diode becomes reverse bias. Why it becomes reverse bias? Because negative polarity at the point A, we apply negative polarity is applied to anode, and positive polarity is applied to cathode. When during negative cycle. Therefore it becomes as an open switch, and there is no closed path. Current will not flow through the current, through the circuit. Therefore here half a rectifier, during this time interval there is no negative cycle is there. Will not get this will not, this voltage or this electricity, this voltage will not appear at the output of the half wave rectifier. After some instant, because with respect to time, every instant the time is changing, polarity is also changing. After a few seconds, what happens? Once again it becomes positive polarity. Positive polarity means now once again it becomes this point A becomes positive charge, and this becomes negative charge. It becomes positive polarity, it becomes negative polarity. Means uh, positives applied to anode, negatives applied to cathode. When we apply positive anode, negative to cathode, what happens? This diode becomes forward bias. When it becomes forward bias, it acts as a closed switch. Current flow, closed switch, and the closed path, current will flow through it. Therefore, during positive cycle, we'll have the output. Therefore, during positive cycles only we'll get the output. Therefore, this is called as half wave rectifier. Remember, when AC supply is there in the circuit, remember, very important, such some things, all professor will not tell all these basic concepts. During positive cycle, current will flow in this direction, like this clock. In this. During negative cycle, what happens? Current will flow in this direction, reverse, opposite. Therefore, it is called as positive half cycle, negative half cycle. During positive polarity, current will flow like this. During negative polarity, current will flow like this. Here also in home also, the bulb is glowing, fan is rotating, because it requires a current. It don't want the polarities, whatever the polarity, whether it is it is coming like this, so clockwise, it is coming anti-clockwise, does not matter. It requires what? Current to glow. Bulb requires what? Current to glow. Tube requires current to glow. Fan requires volt current to rotate. Like it doesn't not depend on the polarities. But even also, if fan is there, they constructed that it will work on AC supply. If you give DC supply, this fan will not work, because they are constructed so that it should work on AC supply only. Suppose to this our home fan, suppose we apply a DC supply, it will not rotate. Therefore, at that time we have to, in fan also, in it is nothing but inside it is having motor. It is called as induction motor. It will works on AC supply. Suppose we give DC supply, then we have to use DC motor. In motor also different types of motors are there. AC motor, DC motor, universal motors. So many concepts are there. So many. This is about the half wave rectifier, how we'll get AC supply is converted into half wave rectifier. Afterwards we'll have so many terms like what is IM, what is IDC, what is ripple factor, what is efficiency. So many terms are there. Ripple factor, efficiency of the rectification. Our rectifier efficiency is only 0.406. Why? Because why efficiency of half rectifier is 0.4? Why the efficiency of the full rectifier is 0.8? Because at the output, efficiency means output by input. Output is this, input is this. We are not getting this complete half cycle here. Therefore, efficiency is less. The efficiency of half rectifier is less. Therefore, so many terms are there that we'll discuss in exam. They will ask, for example, suppose while they will ask if you know all this ripple factor or the efficiency, what is IRMS, everything, then only we can some problems. Here you see, they will ask some problems. The input to the half wave rectifier is voltage 200 sin 50 T. If RL is, they have given RL, for resistance they have given, and they will ask you to find the DC current through the diode, the AC or RMS value of current through the circuit, the DC output voltage, the AC power input, the DC power output, rectifier efficiency. Like they will ask so many at that time. Here they have given solution also. How we have to solve, how we can obtain these terms. What is that is DC output voltage? What is AC power input? What is rectifier efficiency? Like we can suppose you know all these things, then only we can solve the problems. Otherwise you can't solve the problems. You should know all this. What is IRMS? What is the expression for IRMS? What is the expression for ripple factor? What is the expression for that is efficiency, rectifier efficiency? Here efficiency of rectification, it is equal to DC power delivered to the load divided by AC input power from transformer secondary. Suppose you know all such, that is nothing but PDC by PAC. If you know all these concepts, then only you can solve the problem. In exam also, they will ask sometime, halfway rectifier. They will ask explain with night diagram the halfway rectifier. And also sometimes they will ask one problem related to rectifier, like the as I shown this problem. Such problems will be asked in the exam. When they ask for 10 marks, 12 marks. If theory also they will ask for 10 marks. Important. Such question. In next class, we'll discuss in detail about what are the terms which are related to halfway rectifier. Okay, so many interesting concepts are there in basic electronics. We'll discuss one by one in the class also. If time is not there, I will make the video lectures. And also you can ask any doubts related to basic electronics. Okay, okay, thank you.